Right. So this is technological innovation and new media, and this class we discuss about the multicasting IGMP Internet Gateway Management Protocol, and then about distance vector multi-routing protocol. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we discuss about the multicasting, the principle and the definition. Then we discuss about the various multicasting applications. Then we discuss the importance of Internet Group Management Protocol and about the different versions. We discuss about IGMP version 1 packet format and about the message packet format in the IGMP version 2. Then we discuss about the message packet format in the version 3 of IGMP. We discuss about the working of IGMP and about the distance vector multicast routing protocol. Then we discuss about reverse path forwarding RPF. Then finally we are going to end this class with MOSPF, which is nothing but multicast open shortest path first. Okay. So I've given the independent work for you. Please complete them as soon as possible. And at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. So multicast, as you know, it's nothing but not one communication, but it is actually a group communication where the sender will be sending the data to multiple receivers, or maybe the sender will be sending it to multiple nodes present in the network simultaneously. Okay. So multicasting, you can say one to many or maybe many to many communication. So it will be allowing the senders, okay, to send data packets to multiple receivers across the LANs or maybe across the wide area networks. Okay. So maybe you can use it for reducing the data frame of the network. And generally, multicasting, you can work in a procedure similar to the broadcasting. Okay. But multicasting, the information is sent to the specified or maybe targeted users in the network. So maybe this task you can accomplish by transmitting the same individual copies to every user or maybe every node present in the network. So this task you can accomplish by transmitting the same individual copies to every user or maybe every node in the network. But sending the individual copies to each user, it is actually inefficient, and generally it would increase the latency of the network. Okay. So generally, in order to overcome this shortcomings, generally we will have this single transmission. You can actually partition it, or maybe you can split it into multiple users, and generally it will be reducing the bandwidth of the signal. So generally, in order to overcome these problems, generally multicasting will be allowing single transmission that can be splitted or maybe partitioned into several users. So if you can partition or maybe split it, then generally it will be useful for reducing the bandwidth of the signal. So maybe in the sender, okay, so we'll have the targeted receiver, we partition it, okay. This is how it goes with the multicasting. So maybe you can use it in IP or maybe internet protocol for streaming media, and also for video conferencing or maybe webcast, podcast, you can use the multicasting applications. Then we have IP multicasting. So multicasting which takes place across the internet, you can call it to be the IP multicast. So generally it will be having internet protocol to transmit the data, and IP multicasting you can call it to be the multicast trees. So that will be transmitting the information among the different users of the network. Okay. So multicasting, the multicast trees that we are speaking about allows single transmission to branch out for the different receivers. So here the branches are created at the internet routers, and branches are created such that the length of the transmission will be minimum. Okay. So in IP multicast, we'll be having the essential protocol functions. We'll be having like internet group management protocol IGMP, and then protocol independent multicast, which is nothing but PIM. So here IGMP will be allowing the recipients to access the data or maybe the information, And the network routers will be using this protocol independent multicast to actually create the multicast trees. So this is IGMP, Internet Group Management Protocol. So generally it's a communication protocol designed to be used by the host and maybe the adjacent routers even for multicasting communication with the IP networks. So maybe it is making best use of the resources in order to transmit the message packets or maybe the data packets. So multicast communication can have either single sender, one sender, or maybe multiple sender and receiver. And IGMP, as I told you, you can use it for streaming videos, you can use it in gaming as well as web conferencing tools. So it can be used in IPv4 networks as well, and maybe for IPv6, generally the multicasting is supported by the MLD, multicast listener discovery. So this is what you see in the diagram. We have the IGMP query. We have the IGMP reporter being generated from each of the hosts H2, H3 and then H1. So IGMP, it is used on the network layer, as you know, like application layer, session layer, network layer, transport layer. So generally IGMP will be used in the network layer, and this MLD version 1 is also almost the same in functioning as that of IGMP version 2 and then MLD version 2. Okay, that is quite similar to the IGMP version 3. So in the streaming of application, maybe in audio streaming or maybe video streaming, you can use this multicast routing protocol. Either it can be one to many or maybe many to many. So in the games, generally IGMP or Internet Group Management Protocol can be used in the simulation games, for which multiple users generally will join and they will be participating in the networks. So what you call it to be the online games. So we have the web conferencing tools also. So as you know, for the conferencing, like everybody join the meeting at their a time of interest. Okay. So it's a method to meet the people from your own convenience, and Internet Group Management Protocol will be connecting to the users for the conferencing and will be transferring the message packets or maybe data packets efficiently. So in the case of multicast router, we will have the video server, router 1, local multicast router, and then layer 2 switch with the IGMP snooping, and then video client. Okay. So here we have protocol independent multicast. Between the local multicast router and the L2 switch, we will be having IGMP. So this is the traffic that we will be experiencing, and this is the connection, mean local area network connection. So there are three versions. We have IGMP version 1, version 2 and then version 3. For IGMP version 1, it's a nothing but a IGMP communication protocol which will be allowing all the supporting hosts to join this multicast groups using a membership request, and maybe it will have like basic features. But hosts cannot leave the group on their own and they have to wait for a timeout period. Okay, only then they can leave the group. So this is the format. We'll have IGMP version 1 packet format, version 1 type 1 to 2, unused, and then 16-bit checksum. Okay. So then we have the 32-bit group address. So here we call it as the 8 bytes. Okay. So totally we have 32 bits. So everything we will be having version 1 will have 4, type you have 4, and then from here unused will have 8. Okay. And then the remaining will be for the 16-bit checksum. So the version is set to 1, and type 1 for the host membership query. It will be having all the basic features and it will be generating the host membership report. Then the unused, as I told you, it is 8 bits of 0, which we will not be using any point of time. Then you have the checksum. It is actually the ones complement of the sum of all IGMP messages which are generated. And then you have the group address. Group address field is set to 0 when sent and may be ignored when received in the membership query message. So here in the membership report message, the group address field will be taking the IP host group address of the group being reported, and then you will have IGMP version 2, which is nothing but the revised format or maybe the modified version of this IGMP version 1 communication protocol. So it is just like IGMP version 1 will have the IGMP version 2. So it has some added functionality like IGMP version 1 cannot leave the host group at any point of time. Only after the specified time interval, like timeout period, they can leave the group. But here they can leave the multicast group using this group membership. Okay. So this is the IGMP version 2 packet format. Will have type and then maximum response time and then the checksum. Okay. So here in the message packet format in IGMP version 2, we'll have the type, maximum response time and then checksum. So for example, the type we'll specify for 4 bits and then maximum response time will have 8 bits. Checksum the remaining. Okay. So remaining 12 will be experience for the checksum, and then you'll have the 32-bit group address in total. Okay. Right. So here we'll be having the type. Okay, so that is actually in the format of 0x11. Okay, for the membership query, and then for the IGMP version 1 membership report, you'll have 0x12. For the IGMP version 2 membership report, you'll have 0x12, and then IGMP version 3 membership report, you'll have 0x22. Okay, for the leave group, you'll have 0x70. So this is the maximum response time. So that is actually ignored for the message types other than what you have for the membership query. So for the membership query type, it is actually the maximum time or maybe the maximum response time that is actually allowed before sending the response report. So generally the value you can take it as the order of 0.1 seconds, and then checksum like the version 1, it is having the ones complement of the sum of IGMP messages. Then you have group address. It is actually set to 0 when sending the general query. Otherwise, the multicast address for the group specific or maybe source specific queries has to be set. Okay. Then you have the version 3, which was the modified version of IGMP version 2. But only thing, it has additional functionality with the source specific multicast. And then with all the membership reports that is being generated, it is collected, aggregated, and then given. Okay. So these reports are sent to one IP address 224.0.0.22. So this is the version or maybe the message packet format in IGMP version 3. So you have the bit offset 0 to 3, 4, 5 to 7, 8 to 15, and then 16 to 31. At last you will find the checksum, but before that you will have the type of 0x11, maximum response code. Then up to 32 you will have the group address. With the case of 64 bits, we'll have reservation, yes, QRV, and then QQIC, the number of sources, source address 1, source address 2, up to source address n. This is the maximum response time as like the previous examples or maybe the versions IGMP version 2 and 1. It is the same. So this actually is ignored by the message types other than the membership query. So for only for the membership query type, it is only nothing but the maximum time that is allowed before sending the response report. Okay, so that is the time. Okay, so generally the value would be in 0.1 seconds. Checksum, as like the previous cases, version 1 and version 2, it will be the ones complement of the sum of the IGMP message, and group address, it is set to 0 when you send a general query. Otherwise, maybe it can be set for the group specific source messages or maybe the source specific queries or maybe the group specific queries. Okay. Then you will have the reservation. Okay. So it is actually set to 0. Okay. And then for sent it is okay, but received it is actually ignored. Okay. And then yes flag, it is nothing but the suppress router side processing flag. So maybe when this particular flag is being set, then it will be suppressing the timer updates that the multicast routers will be performed on receiving any type of query. So here we have the message packet format in IGMP version 3. Okay, so you'll be having the reports. Okay, like IGMP version 1 report, IGMP version 2 report, IGMP version 3 report upon for the querier. So the router A is nothing but the querier, it will be sending, and the receiver host A, host B, and host C will be sending the IGMP version 1, IGMP version 2, and IGMP version 3 reports. Okay. So QRV is nothing but the querier's robust variable. Okay, so it is keeps on retrieving this QRV value from the most recently received query. Okay, so and then afterwards, then the QRV is set to 0. Okay. QQIC is nothing but the querier's query interval code. Okay, so that is the code that you will be setting. Okay, so that's nothing but an identification or maybe an ID where you can send and then you can receive the queries. And then number of sources, it is going to be the number of the source address which is present in the query. As I told you, source specific or maybe group specific queries, so this field is actually set to 0. And for group and then source specific query, it is actually non-zero. Okay. So source address is nothing but the IP unicast address for the N fields. So you can handle several multicast groups, even dynamic multicasting also you can work on with the case of IGMP. So maybe it can, yeah, it can you can also join or maybe leave membership in the multicast group. You can also add or maybe you can also remove clients also from the group. So communication protocol, like it is operated between the host and the local multicast router. So maybe let us take in the case when the multicast group is created. So multicast group address maybe is in the range of class D, okay, IP address, and that is being forwarded to the destination IP address in the packet. So here we will have level 2 devices, what you call to be switches, which are present between the host and then the multicast router for the IGMP snooping. So IGMP snooping is nothing but listening to this network. Okay, maybe listening to the traffic in a very controlled manner. It is going to listen. That is what you call to be IGMP snooping. And switch is going to receive the message from the host and it will be forwarding the membership report to the local multicast router. So here multicast traffic will be forwarded to the remote routers from the local multicast routers using the protocol independent multicast, so that the clients, maybe if they want to join this particular network, they can send a join message in the query, and the switch is going to intercept the message and it will be adding the ports of the client to the multicast routing table. So this is how it goes with the multicast traffic from the client to the host. We have protocol independent multicast from router 1. Then you will have the local multicast router, and from that internet gateway management protocol. Okay, we have the level 2 switch with the IGMP snooping. So maybe in the snooping, if you can see, it will be listening to the traffic. Okay, and in the very controlled manner, it will be listening. Okay, and from there IGMP, it will be connected to the host. So about the advantages, of course, multicast data is transmitted effectively to the receivers. So actually no junk packets are actually transmitted to the host, which means that we will be experiencing optimized performance with the IGMP communication protocol. Okay. Bandwidth is consumed effectively, efficiently utilized everywhere. So which means that all the shared links are actually connected. And host can leave a multicast group and maybe they can also join another. So they are independent. Okay. But disadvantages with regards to filtering and security, it is not providing good efficiency. Overall, it is providing, but with regards to filters or maybe removing noises or maybe authentication or maybe privacy procedures, it is not providing good efficiency. Also, due to the lack of transmission control protocol, congestion problem will occur in the IGMP, and of course, it is vulnerable to the denial of service attacks, okay, DOS attack. Then you have distance vector multicast routing protocol. So it's a multicast routing protocol which is going to take the routing decision based on the source address of the packet. So here we will be having the routing tree, and whenever the router is going to receive a packet, it is going to forward some of its ports based on the source address of the packet. So here the rest of the routing tree, maybe we'll have like upstream routers, we'll have downstream routers, and routing tree is actually created from the destination to the source. Okay. So here we will be having some tasks like it should prevent the formation of the loops, it should prevent formation of the duplicate packets, and it has to ensure that the path traveled by the packet is in the shortest form. So that is the reason we will go with open shortest path first. Okay. Then you should provide the dynamic membership. Okay. Then we'll have reverse path forwarding. So a router will be only forwarding those packets that have traveled the shortest path. Okay. So for this one, the router pretends that it has a packet to send to the source. Okay, from where the packet has arrived. So in this way, the shortest path, okay, to the sender of the packet is actually computed. Okay, and then if the same route is actually followed by the received packet, it is actually forwarded to the next router and it is actually discarded. So here the reverse path forwarding ensures that the network receives a copy of the packet without formation of the loop. So actually the formation of loop is actually prevented. Okay. So the loop occurs when a packet that has left the router may come back again from another interface or maybe the same interface and then it will be forwarded again. Okay, so here the packet will be forwarded, okay, from here, and if it goes like this means packet not forwarded, so it goes here and in return from B to C it is not forwarded. Okay, C to B it is not forwarded, so only this side we will have the packet being forwarded and in between we will have packet not forwarded beyond receiving router. So reserve path forwarding does not guarantee that there would be no duplicate packets because the network may receive 2 or maybe more copies of it. So it cannot assure the duplicate packets. Okay, and the reason is that the routing is based on the source address. So since maybe it is dependent on the, if it is dependent on the destination address, then we can see what are the duplicate things, duplicate packets that has been transmitting. But here it is based on the source address, so we have no assurance. Okay. So in order to solve this problem, maybe we'll have a reverse path broadcasting. So here one parent router is actually defined for each network and the network would accept the multicast packets for this parent router. So the router will be sending the packets to those ports what you call it to be the parent. So reverse packet broadcasting allows the router to broadcast the packet and generally it will be creating the duplicate packets on the network. Generally if you are able to identify the duplicate packets, then definitely you can reduce the network efficiency. Because duplicate packets are created, network efficiency is actually reduced. Okay. And then you will have reverse path multicasting. So in order to overcome the problem of broadcasting, you will have reverse path multicasting. So here we will go with the desired multicast network tree, which is created using two methods, which is nothing but pruning and then grafting. Okay, so the router can send a prune message to its upstream router. Actually pruning means it's actually cutting the unwanted things. Okay, so router can send a prune message to its upstream router whenever it finds that the network is not interested in a multicast packet. So which means that, as I told you, prune means it is cutting. So the router is going to cut its network from the multicasting, and if the router receives a prune message from all the downstream routers, in turn it will be sending a prune message to the upstream router. Okay, so this is how it goes. Source, okay, to the router. Okay, we will have the leaf without the group members. Okay, and then for everything you'll have a group member. Here it has a group member, here it has a group member, and similarly this one it has a group member. Okay, so it will be sending the messages and maybe this dotted line will designate the pruned branch. Okay, so this is the prune message that we are actually generating through the router. Okay, back to the source. Okay, so through the upstream router, it will be sending a prune message, and a router can also send a graph message also to a upstream router. Okay, if it finds that the network is again interested in receiving a multicast packet. So in this way, maybe the graph message will be forcing the upstream router to again send. That is the reason to again send. If it is interested means it can send a graph message. Graphed means you can actually join. The network is again grafted or maybe joined. So this is MOSPF, which is nothing but multicast open shortest path first. So it is actually the multicast version of the open shortest path first protocol. So it is an extended version of the OSPF, open shortest path first. Here only thing we will have multicast, which means that multicast link state will be used to create source based trees. Okay, so definitely it will be different from the distance vector multicast routing protocol. The difference is that at least like it has the least cost tree in comparison with the shortest path tree. Okay, so that is the advantage of the multicast open shortest path first. Second is that the tree is not made gradually, which means that it is made immediately, it is pre-pruned and maybe it is ready to use.